Okay, section 6.4 is called the normal approximation to the binomial distribution. Alright, let's see, I may have to go over here. A correction for continuity is a correction employed when a continuous distribution is used to approximate a discrete distribution. Sorry, delete. Alright, okay. There's a chart we're going to use on page 355. So let me get out of this. Let's go back to here. Okay. So let's go to, let's see, page 380, 360, I'm sorry. And let's do a couple of problems and let's talk about what this method entails. All right, the first thing we need to do, let's do number 5, okay? All right, number 5 says use the normal approximation to the binomial to find the probabilities for the specific value of x. So letter A, it tells me that n is 30. It tells me that, let's see, p is 0.5. And then it tells me that x is 18. All right. Okay, the next thing I need to do is I need to flip back to page 355. Let me show you what I'm talking about, so that you can kind of follow along, because this is a little tricky. Okay, I'm looking down here at the bottom at this chart, and we were given in this problem that x was equal to 18. So I'm looking at all these choices. This says x equals a. This says x is greater than a, or equal to. X is greater than, less than or equal to, less than. You have to look at what's going on with your problem and apply this chart to it. And it will say the normal approximation to the binomial distribution. All right, also at the bottom, it gives you some new formulas, or formulas that you've already used before, to find the mean and the standard deviation. Okay, so since in this problem we're working on x is 18, I'm going to use case 1, where I have to subtract 0.5, then I have to add 0.5, okay? So if I do 18 minus 0.5, I get 17.5, and if I do 18 plus 0.5, I'll get 18.5. So let's go and actually work this out. So when I set up my equation then, I have 17.5 is less than x is less than 18.5. I have to find the z-scores of both. 17.5 minus, and now I'm thinking, oh my gosh, I don't have the mean. So I have to go back and recall those formulas that we learned when we were doing the binomial distribution, which is n times p. So that's going to be 30 times 0.5, which is 15 for the mean. Okay, so I'll fill in 15 right here. The standard deviation I don't know, and to find the standard deviation, the formula we used was n times p times q. Now if you remember back, that's 30. P is the probability of success, Q is the probability of failure, and you had to subtract that from 1, which is going to be 0.5. Alright, if I punch that in the calculator, I will get 2.74 if I round to the hundredths place. So now I can go back up here and plug in that 2.74. That gives me 0.91. I'll do the same thing with the 18.5. That gives me a z-score of 1.28. Just like we've done all these times, I'll go to my z-score chart, I'll find this z-score, find those probabilities and subtract them. So that's 0.8997 minus 0.8186, which gives me an answer of decimal 0.811. Alright, let's do one more problem in this section. Let's do number 13. Okay, number 13 says, in a recent year, 56% of employees offered a customer-directed health plan. This type of plan typically combines a high deductible with a health savings plan. Choose 80 employees at random. What's the probability that more than 50 offer a CDHP? Okay, so the probability of success is 0.56. N was 80, and it wants to know more than 50. Okay, it says to use the normal approximation to the binomial distribution. So I need to go to that chart. I need to look up more than 50. In that chart, it tells me that I have to add 0.5 to that. So I'm actually going to find the probability that x is greater than 50.5. Alright, I have to find some more things. I have to find the mean, which is n times p. Okay, I believe that's going to give me 44.8. I have to find the standard deviation, which is the square root of n, p, and q. And that is 4.44. Alright, now I can plug in my z-score formula, minus the mean, over the standard deviation. That gives me a z-score of 1.28. Okay, that's the only one I have to find this time. I go find it, it's 0.8997, but more than means I have to subtract from 1. So my answer is decimal 100.